Did you know the cannabis plant is over 27 million years old? Welcome to Introduction to the Cannabis Plant. This plant has been found all around the world and has a fascinating history. Today, Dr. Russo is going to tell us all about it. We'll learn about the morphology of the plant, we'll learn about where the medicine comes from, and we'll learn all about its evolution through modern day times. Dr. Russo, take it away.
Thank you, Nisha. I'll go ahead and share my screen. Okay. Well, welcome everyone. So we have our introductions, which you're welcome to study separately. So the objective of this module is to learn a little bit more about the cannabis plant itself. So cannabis sativa, or cultivated cannabis, is an ancient medicinal plant that has been prohibited in the USA since 1937. This presentation will provide an introductory focus on its botany, uses, and cultivation practices, all topics that will be recurrent with more in-depth treatment as the courses progress. So here we have it. I like to call this the 4 Fs: food from the seed, fuel from the seed oil, fiber from the stalks, and pharmacy, if you'll allow me this misspelling, for the unfertilized female flowering tops, what's called ganja in India, and sinsemilla in Mexico. So it's the history of the plant is very interesting. John McPartland has done a great deal of work looking at pollen deposits and trying to show age and origin of cannabis. But based on pollen analyses, cannabis is about 27.8 million years old, at which time it diverged from its related species, Humulus, better known as hops, and the best evidence is that it originated in the Tibetan Plateau. Other people have thought Central Asia, but again, this isn't definitive at this point. In another article, McPartland and colleagues were able to show that cannabis is indeed indigenous to Europe as well as Asia, if you make the separation there. The methodology of this was interesting. It was what is called an ecological proxy method. So looking at fossil pollen residues and what other plants were around at the time. Hops pollen and cannabis pollen are very much resemble one another. But in the presence of other plants, you can distinguish cannabis, which is often more out in the open, as compared to hops, which is more likely in forested areas. So cannabis pollen appeared in continental Europe um, uh, very long ago, prior to the Ice Age, and then eventually got to England and then to Ireland. And we'll likely have a separate unit talking about the history of cannabis in Ireland. We'll have a series of photos and demonstrations from an excellent botanical review by Ernest Small. And this is a nice picture that really shows you the habit of the cannabis plant. So again, may have originated in Central Asia or Tibet. Cannabis prefers well-watered, loose, fertile soils, as would occur in alluvial plains or along rivers like this. It does like fertilization, and we have equine species helping out here. Cannabis throughout its history has been known to have a close association with humans. It's what's known as a camp follower, meaning that where ancient humans were nomadic, cannabis tend to follow. One of the issues is whether there is wild or feral cannabis today. I understand from people that have been there, there are places in Kazakhstan where there just seem to be kilometer after kilometer of what appears to be wild hemp, with no evidence of human husbandry. At this point, um, it's unclear, but it is clear that it's been heavily utilized by humans. Of course, cannabis is not just a drug. It's been useful throughout its history as a fiber source. And this is a demonstration how hemp is retted. Retting means to throw the stalks into a body of water and allow them to begin to rot. And in this, there's a separation of the fibers. More from Dr. Small. You see the different shapes of plants. Uh, Growing for hemp, you want a long, thin, unbranched plant. So the planting density is very high. To grow as a drug, you want more of a bush form and allow some spacing in between them. Again, another demonstration of different uses. Obviously, it's possible to selectively breed to favor different end products. Now, it's been a truism in the past, at least, that a given variety is best for one thing, whether it be for seed production for food, for making fiber for clothing, or as a drug. But as we'll see, there are exceptions to this. Our friend Rob Clark did a lot of work in Nepal in an extremely western area called Darchula that you see borders on Tibet and India. This is a field of cannabis along a hillside. Um, this is densely sown. The plants are 2 meters or less in height by the fall. And this is what the mature plants look like. This would be a female plant that is seeded, but also has a great deal of resin production. And the person on the right is hand rubbing what they call charas, elsewhere called hashish. Um, and so this breaks the glandular trichomes and then is scraped off of the palms. You see on the left, carrying stalks up the hill, in the middle, preparing these for fiber production, and on the right, use of a mill to make the fiber. In this picture, we see three products, all from the same cultivars of cannabis. So at the bottom, we have sticks of charas. That's what the hashish looks like after it is scraped off and rolled into these long, thin cylinders. And we have the seeds that are used to make a condiment called bang chortney or chutney. You have the recipe on the left, which you'll be able to consult later. I can attest to this being delicious and an excellent accompaniment to any kind of Indian food. And finally, in the background, we have fiber, coarse fiber, um, for cloth, all from one plant. Now, a little bit about synthesis. This is the normal pathway of biosynthesis for cannabis, what are called pentyl cannabinoids, meaning that there is a 5-carbon side chain. 1, 2, 3, 4, 5. So with these precursors, we have a combination of olivitolic acid with geranyl pyrophosphate. The mother of cannabinoids is cannabigerolic acid. You'll notice that the cannabinoids are in the acid form in the raw state. And it's only with decarboxylation, the loss of the CO2, that we get the subsequent products, which would be THC, CBD, and CBC. However, the plant is versatile as its enzymes are as well. So the plant has the capability to use different substrates. So if the geranyl pyrophosphate combines with divarinic acid, it makes propyl cannabinoids. So we have 1, 2, 3 carbon side chains. So there's a whole series of these in the plant as well. And the enzymes that make them are the same as the ones for the pentyl cannabinoids. The late Professor Meshulam called this an example of nature's law of stinginess, trying to get the most effects from one mechanism and having these enzymes that are somewhat promiscuous in their ability to produce different end products. I thought of a different name for this, tongue in cheek, enzymatic substrate promiscuity, another form of ESP. In terms of distribution of THC or the cannabinoids in the plant, there's definitely a hierarchy. The highest, these would be examples from GW Pharmaceuticals, done by David Potter, PhD, and this is from his thesis. So the unseeded female flower, Ganja or Sinsemilla, has 18 times what is present in the leaves, and almost 3 times what is present if it is a seeded variety. The plant has only so much energy. To make seed requires a great deal and will detract from phytocannabinoid production. You'll note that there's almost no cannabinoid production in the stems, nor in the roots. Occasionally it's been reported there, but for all intents and purposes, the clean seeds and the roots have no cannabinoids in them. Where this is produced best is in the unfertilized female flower, what's called the capitate glandular trichome. So this is on a stalk that supplies nutrition from the plant to the secretory cells that elaborate cannabinoids and terpenoids within an envelope in this spherical area. So, properly speaking, it is these capitate glandular trichomes that provide the active pharmaceutical ingredients or APIs of most medicinal cannabis preparations. Now, that's not the only kind of trichome there is. There are a couple of others. They're the rare bulbous trichomes, and there's also cystolithic hairs that are sometimes called trichomes. So these would produce itch on the skin, and they're really super abundant in hops plants, more than cannabis. But if we compare the diameter of the capitate glandular trichome to the sessile trichomes that sit on the leaves, there's about 100-fold difference, 2 orders of magnitude. So obviously, this has a much greater volume than this. Also, there's qualitative differences. In the flowers, there tend to be a predominance of the lower molecular weight monoterpenoids, whereas the more bitter, higher molecular weight sesquiterpenoids are preferred in the leaves to prevent grazing. So this is from an book chapter, an article that I did with Jehan Marcoux a few years ago, and it shows the different parts of the plants. And there's quite divergence of what they produce. As mentioned, the fan leaves are very low in cannabinoids. They favor sesquiterpenoids over monoterpenoids. They do have flavonoids and a substance, strong anti-inflammatory called cannaprine that we'll hear about later. When the flower is fertilized, the cannabinoids probably top out at about 13%, but they could be as high as 30% in the unfertilized female flowers. And again, monoterpenoids over sesquiterpenoids, and it can be 4 or 5%. If we look just at the trichomes, the concentration of the cannabinoids can be about 60%. The stems, again, good for cellulose, but extremely low concentration of cannabinoids. Then we have the seeds, which are a product unto themselves. No cannabinoids, no terpenoids, but very high in a highly digestible protein called edestin, about 35%. Also 35% of essential fatty acids. We'll hear more about these later, but particularly GLA, gamma-linolenic acid, which is very rare in nature. It's in mother's milk, borage seed, evening primrose, and in hemp seeds, making it a very useful nutritional source. The seed sprouts would have similar components, but after they've been grown a few days, they also produce canned flavins of flavone with very strong anti-inflammatory principles that we'll hear more about. And then the roots, again, no cannabinoids, but they produce triterpenoids. So these are 30 carbon compounds that you don't find elsewhere in the plant, and some alkaloids. For decades, alkaloids were sought in the flowers, but there are not any. Now, there's always been controversy about how many species are in the genus Cannabis. Um, for a couple of hundred years before Linnaeus really developed binomial Latin nomenclature, there was an entity called Cannabis sativa, or cultivated cannabis. So this was in the 18th century. However, shortly thereafter, Lamarck in France described what he thought was a different species that he called Cannabis indica because it came from India. However, note that this was a bushy plant of moderate height with very narrow leaflets. And that, if it were a separate species, would be what should be the description for subsequent use of the term. However, the shape of things does not predict the biochemistry, as we'll see. Now, full disclosure, Professor Schultes at Harvard was one of my mentors, but he would admit to you that he was not a taxonomist, a scientist who decides what's a species and what is not. In the 70s, he went to Afghanistan at a time when it was safer to do that. But he thought that there were three species of cannabis. Cannabis sativa, which would have been a tall, thin plant typical of what was found in Europe in prior times. Cannabis indica, he called, but this was a 1 meter plant. It's found in Afghanistan. And we'll see pictures that this looks very different from what Lamarck described. And also Cannabis ruderalis, less than 1 meter, without branching. Ruderalis means roads, so this would be found along roadsides, say in Russia, growing wild. Now, to show the confusion, this is David Watson by a Chinese hemp seed plant that he grew. You see it's very tall, like a quote sativa. But these are the leaves, very broad leaflets that would be go along with Afghani sourcing in most people's minds. And then plants being grown in the Reef Mountains in Morocco without a lot of care, unbranched, and again about 1 meter high, resembling ruderalis. But you could tell nothing of the chemistry of these based on the shape of the plant or its leaflets. Carl Hillig tried to separate the different types of cannabis based on their biochemistry. And in this study, he thought that terpenoids provided the best demarcation between chemovars, chemical varieties of cannabis. And these designations, WLD means wide leaf drug. It should be leaflet, strictly speaking. And we'll see more examples of this. NLD is narrow leaf or leaflet drug. Right. Hillig's idea was that indica originated in Afghanistan and spread east, and sativa somewhat north and spreading both east and west. Again, current thinking, and I have to admit I've been on every side of this issue, but the current thinking is that cannabis sativa encompasses all the types of cannabis, but that's based in part on the fact that every type of cannabis can hybridize and produce fertile offspring with any other type of cannabis. Um, from Clark and Merlin's book, this shows the distribution of the different types around the world. Again, narrow leaf drug, broadleaf or leaflet drug. You see that both of those got to the US. NLH is narrow leaflet hemp, what might be growing wild in the Midwest, what's commonly called ditchweed. Back to Professor Small, looking at different types and some definitions that have been imposed. So drug type has something higher concentrations of THC, lower concentrations would be called hemp, and making a distinction between domesticated or spontaneous ones and wild types. But again, some of these are artificial distinctions. There have been numerous attempts to look at the biochemistry and try and make distinctions. But cannabidiol chemovars aside, all the cannabis that they examined, and there were many different varieties, were drug chemovars that expressed high concentrations of THC. And in agreement with Hillig, they saw a clear chemical demarcation from differences in terpenoid content. Right. Another study by Soller et al. So-called strain names, I'd point out that there are no strains in cannabis. There are strains of viruses, strains of bacteria. Better term is chemovar or cultivar. But strain names do not represent genetic identity. They found that hemp was more closely aligned with indica than sativa, which would be counterintuitive because most hemp has come from Europe and are plants that have typically been called sativa in the past. As you see how confusing and contradictory it can be. Now, we're going to transition into what seems like a tangent and talk about pesticides. Now, obviously, these come from humans. They don't come from the plant, but this is a very important topic that hasn't gotten the attention that it deserves. I know what pesticides can do when there's an exposure in excess. When I was a pediatric intern in 1978, a boy was admitted to the intensive care unit with what was called a cholinergic crisis due to being exposed to high concentrations of organophosphate pesticides from working in a field. He was having constant seizures. He was comatose and had to be on a ventilator and had all these other problems. But after treatment with the ventilator, administration of atropine, which reverses some of the effects, also pralidoxime, and treatment for his seizures, he improved. He couldn't remember much of what happened before and was lost to follow-up. But it was a very sobering reminder of how toxic these compounds can be. The World Health Organization estimated in 1990 that there were 3 million hospital admissions a year for pesticide exposure, leading to 220,000 deaths. Now, these were concentrated in certain areas, USA being a culprit along with Thailand. So half the cases came from only 2 countries. these are designed to get into the body of an insect, but get into the body of a human as well. So exposure can occur via food, skin, breathing, or any combination. There have been cases of cancer, Parkinson's disease, and other causes of morbidity and premature mortality um, that have been described, but the exact number that are related to pesticides are not known. There had been a survey in California in 2014 of laboratories that could do the kind of assays to look at pesticides, but they estimated at that time that incidence was only about 1 to 2%. So subsequently, California analytical laboratories found that 15 to 35% of samples submitted to them were positive for pesticide residues. Um, some of the labs pointed out that they didn't want to publicize they were providing this service or what they were testing for because they thought that people would this would lead people to use different agents than what they were testing. This has been a constant problem in the industry. Subsequently, there was a published survey of cannabis contamination in California by Raber et al. And they found 8 different pesticides in a third of the samples. They did not measure the concentrations, and they didn't publish this. Washington State, where I live, legalized medicinal cannabis in 1998. But it was pretty much unregulated. Then in 2012, there was full legalization, if you will, of recreational or adult use cannabis. And although it had been recommended by a panel studying this, there was no requirement for pesticide testing. Um, and Another problem in the industry is because of the forbidden status of cannabis, there's no US organic certification of cannabis. There also are no EPA, Environmental Protection Agency guidelines on acceptable pesticide levels for a smoke product. There are for other crops, of course. There was some informal testing done prior to 2016. And it was felt at that time that 5 to 10% of tested cannabis flower samples had pesticides on them. A study that we'll look at showed that 70% of pesticides that were placed on cannabis to test what it got into the smoke showed 70% did. And that's this study, Sullivan et al. They looked at these different pesticides by different methods. Water pipe with filters, water pipe without filters, glass pipe. And you see the different rates, but it gets to the point that with a glass pipe without any filtration, that it's up to 70% of these agents could get in. So with colleagues, I felt that it was necessary to study the situation contemporaneously. This is in 2016. 26 distinct cannabis samples were purchased on the legal market. 24 of these were concentrates and 2 were flower. These are all from legal stores. There was a witness chain of evidence taken to a state lab with a license. So how this is done shows you how intensive this is. The sample needs to be homogenized, weighed, internal standards added. It needs to be dried and buffered, centrifuged, and then put in an autosampler device. This is the kind of equipment that's necessary. So the fluid above the crud is injected into a LCMS, liquid chromatography mass spec. machine. This one was done on Shimadzu equipment, and 200 different analytes were measured. The results were very sobering. 22 of the 26 samples tested positively for pesticides. That's almost 85%. Many of them had multiple contaminants, and these weren't just a little bit. Sometimes tens or hundreds of thousands of parts per billion. And so much so that it exceeds what the machine can measure. Just in these samples, there were 24 different pesticides, including all classes: insecticides, miticides, fungicides, insecticidal synergists, and growth regulators. In different chemical classes: organophosphates, organochlorides, carbamates, neonicotinoids, etc. The latter being extremely toxic to bees and killing bees of any type, whether it be a worker, a drone, or the queen. In conjunction with colony collapse disorder, this is another factor in the almost disappearance of honeybees from North America. This is just a table of all the different agents that we found, along with summaries of what they can do to humans that are exposed. And this is in the article. Here we'll have links to this, and this can also be found at ethanrusso.org at the library tab. Now, again, although there are no recognized standards for what is allowed for pesticides on cannabis, the Oregon state standards allow 0.1 part per million of certain pesticides. That would be equivalent to 100 parts per billion. And most of what you're going to see is in the latter unit. So remember 100, whether it's below or above that, to get the scale of things. So this is one example, a thing called Doug's Killer Hash, which I think is ironic considering that piperonal butoxide was at almost 8,000 parts per billion, which would be 77 times the allowable limit if that were applicable. And then etoxazole as well, 15 times. Piperonal butoxide is a pesticide synergist. This is found at a rate in one sample 77 times what would be allowable. This is a possible carcinogen. It could produce developmental or reproductive toxicity, and it's a suspected endocrine disruptor. Could do things like cause premature breast growth in young girls. Another example in what's called juju joints, this is from an extract. This had gross contamination with 9 different agents, and you see, again, tens and even hundreds of thousands in the case of boscolid parts per billion with this. So clearly not something that's worthy of human ingestion. Another example, bifenazate, which is to kill mites. In this sample, 152 times the allowable limit. It has slight acute toxicity, but could contaminate the groundwater. Again, a possible developmental or reproductive toxin and endocrine disruptor. A lot of cultivated cannabis came from Afghanistan originally, its genetic ancestors. That was a dry climate. And so molds are a big problem in cannabis culture, particularly indoors. So a lot of fungicides are used. Boscolid is one of those. This is over 1,000 times the allowable concentration. A possible carcinogen, again, questionable developmental and reproductive toxin, and a known endocrine disruptor. Fenpyroxamate, an insecticide miticide, as you see, again, developmental reproductive toxin and possible endocrine disruptor. Myclobutanil was very popular, a developmental and reproductive toxin. pyraclostrobin, fungicide, same kind of issues. We can go on and on. Carbaryl, a carbamate insecticide. This is what's known as a bad actor, meaning that it has known toxicity in a number of different systems. So it's a cholinesterase inhibitor. It could cause the kind of reactions seen in the young man that was in the hospital in Phoenix in 1978. Carcinogen, developmental and reproductive toxin, and a suspected endocrine disruptor found in a sample at 255 times the limit. So what is the risk of contamination? Well, we see here a hierarchy. Outdoors, if we look at the percentage without detectable pesticides, 2/3 in outdoor samples. For mixture, it's lower. Indoors, 21.4%. So a hierarchy is developed. Outdoor culture is the best. There's the least likelihood of insects or need for pesticides. Greenhouse is a controlled environment, hopefully, but higher risk for pests and need for pesticides. Indoors, without supplemental light, it's got the most humidity. Bugs get in, and certainly molds are another risk factor. So looking at indoor cultivation, which is the source of many or most cannabis in commerce, this is really a byproduct of prohibition in that it had to be a clandestine, hidden activity to grow cannabis before there was any sort of legalization, at least at the state level. Being indoors maximizes the humidity of fungal, bacterial, and insect growth. So the conditions are the most difficult in which to control pest problems. This is not to say that it can't be done with scrupulous adherence to standards. Greenhouses are glass houses, as we see here for the glass house at GW Pharmaceuticals. In this particular instance, they used organic compost. It was climate controlled as to temperature, light cycles, and humidity. When there were bugs, they were treated with other bugs through what's called the Integrated Pest Management, or IPM. Also, there was use of pheromone traps. So these are sexual attractants to bugs, and no use of pesticides, because this was for medicinal use for the pharmaceutical market. Outdoor cultivation, we see our friend here, Valerie Corral. This is where the plant grew up and belongs. So you have plants rooted in soil. It has better availability of things it wants. And this produces healthier plants in general with fewer pest problems. And there might be some natural pest predators, ladybugs or whatever. There's also the possibility for companion plantings to attract the bad bugs away from the crop of interest. This is not absolutely proven, but we have good anecdotal evidence from good organic culture outdoors that this produces more diverse cannabinoid and terpenoid profiles, and this is something we'd like to prove. But outdoor culture is only practical in a legal environment. When I took this picture in 2002, it was only a few weeks before this farm was raided by the DEA. There's an excellent book available, now 24 years old, unfortunately, Hemp Diseases and Pests by John McPartland, Rob Clark, and David Watson. Still an excellent book. A second edition is in preparation, and we look forward to that. In terms of pest treatment options, we've seen again this hierarchy: indoor better than greenhouse. Indoor greater risk of pests, more than greenhouse, more than outdoors. Hygiene is essential. Plants should be looked at daily. It's possible outdoors in particular to use trap plants like bush beans. you should try to control controllable parameters where you can, use beneficial insects, use those to treat when pests are seen, um, and judicious use before flowering with organic agents. A very simple method is yellow sticky cards. These attract many flying pests. It's a mechanical control. Nothing gets on the plant itself, so there's no toxicity risk. Just to show how many products are out there, these are federally registered pesticides. This is only the first page, the first of 22 pages. There are hundreds of them, and you see how difficult it would be. Many of these are combinations too. How difficult it'd be to cover all these if you were doing the monitoring program for pesticides. Um, this is the way one should rig up when using these kind of agents. I would point out that, yeah, I scared some of the neighbors, but it was totally organic, what I was using. And reportedly, fruit could be eaten the same day that spraying occurred. But it includes a Tyvek suit, gloves, hard hat, respirator, and goggles. So there's no reason that you would want to breathe this stuff or get it on your skin. So this is a wise practice. Um, this is from Applied Bionomics. Pest control recommendations. You'll see the green arrow at cannabis, not marijuana. What beneficial bugs are recommended as treatments. Here we see an example of that from hemp diseases and pests. So a spider mite is on the right is attacked by a predatory mite. So using fire to treat fire. So these are my recommendations adapted from an excellent reference, Feldman in 2015. We believe that people should follow standards prohibiting all EPA registered pesticides, allowing exempt agents and encouraging organic practices. I believe that all cannabis in commerce should be tested by certified labs. Of course, this is going to add to the cost. It should not be allowed to use pre-plant pesticide use on soil or in grow rooms because there will be residuals. All this should be documented with labeling at point of sale. I have not seen that personally, but this would be a recommendation. It's absolutely essential that all personnel working in such environments know proper safe cultivation techniques and are protected from toxic exposures. I will read this. The unregulated commerce in cannabis with respect to pesticide usage and lack of available organic certification have resulted in widespread abuse of the legal cannabis market system. Again, this is a byproduct of prohibition. Cannabis concentrates in 2016 accounted for 60% of legal sales in the state of Washington, and also were the base for burgeoning commerce in cannabis edibles. I feel that pesticide contaminated products are a clear and present danger, particularly in young patients with epilepsy and other neurologic conditions. We also don't know what kind of increased risk of cancer development there'll be down the road from these cumulative toxic substances. In the future, regulation and monitoring with allowance for organic certification and use of IPM, integrated pest management, without synthetic pesticides are the things that should be done to rectify this looming public health threat. I was really appalled by the gross levels of contamination in the legal market in Washington state. Certainly it's an indictment of the neglect of regulatory management, as well as industrial oversights and unscrupulous practices. this should not be taken as evidence that cannabis is too dangerous for therapeutic use when people do it properly. So again, this isn't native to the plant. This is a problem with how it is grown and distributed. Now let's shift gears again. Um, uh, Talking about different classifications of cannabis. Um, it'd be good to have a description of its shape, content, and purpose. Basic classes based on the primary cannabinoid. That would be type 1 for THC predominant, type 2 for THC CBD. Type 3 would be typical hemp, CBD predominant. But we've also got additional ones. CBG type 4, type 5, zero cannabinoid, and perhaps adding type 6, tetrahydrocannabivarin. And we'll talk more about these. A description of the plant morphology, its shape, whether it's broad leaflet, compact versus tall and spindly. Of course, we're most interested in the cannabinoid and terpenoid content. It would also be good to have descriptions of the scent, taste when vaporized or put into an edible. And what do people say about how they use it or the effects? And these would be patient-oriented attributes. So a very good way of typifying this can be done on one page, what's called Phytofacts, which was developed by Mark Lewis, PhD at NAPRO Research. From the top, you see the percentage of cannabinoids and terpenoids, the different ratios of the components, donut to show their proportions. Down at the bottom, very easy to understand concentrations of the 17 most predominant terpenoids in cannabis. You see that this one is beta-caryophyllene dominant with high degrees of limonene and low myrcene. The aroma and flavor, you see earthy, camphoraceous, spicy, citrusy. And very importantly, what consumers say about the effects. High in comfort, inspiration, whatever that means, calmness, but energy. So interesting profile. And just a word about land races. Land races are chemovars, chemical varieties of cannabis that have been grown outdoors in a specific geographic location that are best adapted to the ecological local conditions. Lamb races grow better than newer hybridized plants that have largely replaced them, and this is true throughout the world, especially in traditional cannabis growing areas, Jamaica, Colombia, Morocco, Afghanistan, and Thailand. Along the way, many wonderful and advantageous traits have been lost, and it's hoped that efforts will go forward to preserve this genetic legacy, which might include disease resistance as well as a broader profile of therapeutic ingredients. And that's that for this class. I'll stop sharing.
As always, thank you. That was excellent. So I know that you are a huge proponent of organic culture. Will you talk a little bit about regenerative culture?
Sure. So regenerative culture is like organic plus. So in this instance, there often is an effort to use available local materials as the sole source of inputs. An example would be what's called Hugelkultur, a German word that means mound culture. In this situation, on a large plot of land, one would use branches or even logs that would be put into a shallow pit at the bottom, which would be then covered with plant refuse, followed by and leaves, that kind of thing, followed by compost, and then good garden soil, or and manufactured organic soil mix. Through this, it's possible to do a number of things. Between all those different layers, there'd be an abundance of about every kind of element or compound that a plant would like. It also is very good at promoting mycorrhizal attachment of the roots. So the symbiosis between the cannabis roots and fungi that break down the vegetable matter. Also for native bacteria to grow properly. Um, there's some evidence to say that under these conditions, the plant can pick and choose what it wants and provide the best nutrition. And as I alluded to previously, what we see typically when cannabis is grown in such an environment is a very broad diversity of cannabinoids and terpenoids. So it's not just THC. We'll see higher amounts of CBG, CBC, CBD, as well as a wider variety of terpenoids than usual. A situation where it's not just myrcene, as is commonly seen on cannabis and commerce. Um, uh, Additionally, the need for remedial efforts, whether it's to treat fungi, bacterial diseases, or insect predation, seems to be much lower under these kind of conditions. Um, and there's no fouling of the watershed or that kind of thing. So that would be an example of regenerative agriculture.
Thank you very much. So just like tomatoes, we have many different varieties of cannabis that come in lots of different shapes and sizes and colors and flavor profiles, just like you've outlined in your presentation today. And several years ago, when you and I attended a cannabis conference, it was a Cannabis Cup, there were hundreds of different samples of dried cannabis flowers. And I was really blown away by the array of colors that appeared in the samples that were being shown. Can you talk a little bit about what might drive the color? Right now, purple is really popular in dispensaries across California and many other markets as well. And I've seen black cannabis and everything from light green all the way to black. Can you address that?
It's most likely that this is an aesthetic sort of issue. In other words, purple's popular, but there might be a perception in the public that this equals better quality in some fashion. I don't know that that's been substantiated at all. I think it's great for people to seek out flower that looks nice, but they should be more interested in what its ingredients and effects are. Um, so, um, appearance has to go along with chemistry to make a wisest choice.
Sure. Well, thank you. So my final question is about laboratories. So the information that you've provided about pesticides is concerning, and I think anybody watching is likely to take heed. So are modern cannabis laboratories capable of identifying that all of these pesticides you've warned us about could be in their cannabis?
They may, but it's more likely they may not. Um, Again, this is very expensive equipment, tough assays to do. Where do you stop? Is 10 pesticides that you assay for enough? It could be 200. So I think people have to be very savvy consumers and ask these kind of questions. The other problem with laboratories is quality control isn't necessarily there. There's tremendous variation from one lab to another, and it's subject to what's called THC inflation. We've seen a phenomenon where the labs with the highest results, whether they're accurate or not, they stay in business. And the probably more scrupulous labs that might give a lower THC number go out of business because people don't want to, the growers don't want to use them anymore. Again, um, people have their own motivations. I blame this all as a byproduct of prohibition. In a legalized and regulated environment, this all can be controlled.
Well, it sounds like the clear moral of the story is to utilize products that are made from organically or regeneratively grown cannabis.
I would like that.
All right, well, thank you so much. Our next module will take a much deeper dive into the components of the cannabis plant. We look forward to seeing you soon.
Thank you.